Practice problem 2 on light. Let's determine the speed of light using a very old method that was used well before the Michelson method. About 150 years ago, Armand Fizeau used a toothed wheel to measure the speed of light. One particular wheel had 150 teeth with 150 spaces or gaps between them. The teeth and the gaps were of equal width. Light travels through the gap and is reflected back along its path by a mirror 8 kilometers away. At what speed must the wheel rotate in order for the light to arrive back at the wheel and pass through the gap next to the one through which it first passed? So the light is going to travel 8 kilometers or 8,000 meters, and then it will be reflected, and then it will travel a total distance of 16 kilometers or 16,000 meters. So the first equation we're going to use is time for light to make 16-kilometer round trip equals time for wheel to make 150 to make 1/150th of a turn. So what is the amount of time the light takes to make one round trip? That's 16 kilometers, and again the time for 1/150th of the time. So you're going to see that the time round trip is going to be 16 times 10 to the third meters divided by the speed of light. So the time it takes for the light to come back there and back is going to be 5.33 times 10 to the negative fifth seconds. So that'll be the time for the light to come back. Now, the speed in revolutions per second would be 101/150th revolution per 5.33 times 10 to the negative fifth seconds, which would be 125 revolutions per second, and that'll be the final answer. The final answer is 125 revolutions.